Week past Earth. I received the call from Harvard at 2:47 a.m. Eastern Time. When your phone rings at that hour, and the caller ID shows the Harvard-Smithsonian Center for Astrophysics, you know something extraordinary has happened. I was immediately wide awake. Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard, was on the line, and I could hear the tension in his voice, a mixture of excitement and something else. Uncertainty, perhaps. Or maybe it was awe. Michio, he said, dispensing with pleasantries. We've been monitoring 3I Atlas with the radio telescope array, and we've detected something that defies explanation. There's a signal. It repeats every 88 minutes, like clockwork. And it's not natural. It can't be natural. I've known Avi for decades. He's one of the most brilliant and, importantly, one of the most careful scientists in the field of astrophysics. He doesn't make claims lightly. He doesn't call colleagues in the middle of the night unless something truly groundbreaking has emerged. I told him I'd be on the next flight to Boston. 12 hours later, I was sitting in a secure conference room at Harvard, surrounded by computer monitors displaying data that would change everything we thought we knew about our place in the universe. The signal was there, undeniable, repeating with such precision that it made our atomic clocks look imprecise by comparison. Every 88 minutes, not approximately, not roughly, but exactly. 3I Atlas was emitting a burst of electromagnetic radiation across multiple frequencies. Let me explain why this is so significant. In nature, we see periodic phenomena all the time. Pulsars rotate and emit beams of radiation that sweep past Earth like cosmic lighthouses. Some stars pulsate with regular rhythms. Planets orbit their stars in predictable patterns. But natural periodic phenomena always have some variation, some drift, some irregularity. They're governed by physical processes, rotation, oscillation, orbital mechanics, and these processes are subject to perturbations, to friction, to the messiness of the real universe. The signal from 3I Atlas showed no such variation. Over the course of 2 weeks of continuous observation, it had repeated 227 times, and each repetition occurred exactly 88 minutes after the previous one, down to the microsecond. This level of precision is what you'd expect from an engineered system, from a clock, from a transmitter, deliberately designed to broadcast at regular intervals. It is not what you expect from any known natural phenomenon. The team at Harvard had assembled the world's foremost experts in radio astronomy, signal processing, and pattern recognition. Dr. Sarah Ballard, an expert in exoplanet detection, had been analyzing the signal structure. Dr. James Gillichon, a specialist in stellar dynamics, had been modeling possible natural explanations. And Dr. Rebecca Chen, whose work in quantum information theory had earned her a MacArthur Fellowship, had been examining the signal for embedded information. What they showed me that morning made the hair on the back of my neck stand up. The signal wasn't just a simple pulse. It was structured, layered, complex. At the broadest level, yes, it repeated every 88 minutes. But within each 88-minute cycle, there were sub-patterns, variations in frequency and amplitude that created a kind of internal architecture. It was like listening to a heartbeat and discovering that each beat contained a symphony. The frequency spectrum was particularly revealing. The signal had sharp peaks at specific frequencies that corresponded to the hydrogen line at 1420 MHz, the most abundant element in the universe, and the frequency that SETI researchers have long considered a logical choice for interstellar communication. But it also had components at frequencies related to fundamental physical constants. The fine structure constant, the ratio of the electron mass to the proton mass, even what appeared to be references to the cosmic microwave background temperature. It's as if someone is speaking to us in the language of physics, Avi said, pointing to the spectral analysis on the screen. These aren't arbitrary frequencies. They're frequencies that any technologically advanced civilization would recognize as meaningful, as deliberate. I spent the next 3 days at Harvard, working with the team around the clock. We eliminated every possible natural explanation we could conceive. Could it be some kind of rotational phenomenon? No. The signal was too stable, and there was no corresponding change in brightness or spectroscopic signature that would indicate rotation. Could it be pulsations driven by internal processes? No. The energy requirements would be impossible for an object of 3I Atlas's size. Could it be some interaction between the comet and the solar wind? We modeled every scenario we could imagine, and none of them produced anything remotely resembling what we were observing. Then, Rebecca made a discovery that elevated this from mysterious to potentially revolutionary. She had been analyzing the fine structure of the signal using techniques borrowed from quantum information theory, looking for patterns that might indicate encoded data. What she found was astonishing. Within the signal, buried in the modulation patterns, there appeared to be a mathematical sequence. It started simple, prime numbers, 2, 3, 5, 7, 11, 13. Then it progressed to more complex mathematical constructs, Fibonacci numbers, prime factorizations, even what looked like the beginnings of a proof of the Pythagorean theorem. This was the smoking gun. Natural phenomena don't broadcast prime number. They don't encode mathematical proofs. This was a message, and it was designed to be recognized as such by any species capable of radio astronomy and mathematics. The choice of an 88-minute interval suddenly made sense. It was long enough to be clearly distinct from natural periodicities, but short enough to be easily monitored. And 88 itself is interesting. It's the number of keys on a piano, the atomic number of radium, and in some cultures, it's considered a symbol of fortune and infinity. We needed to verify this independently. I contacted colleagues at the Arecibo Observatory in Puerto Rico, at the Parkes Observatory in Australia, at the Very Large Array in New Mexico. Within 48 hours, teams around the world were confirming our findings. The signal was real. It was there, and it was repeating every 88 minutes without fail. The implications began to sink in. For decades, we've searched the skies for evidence of extraterrestrial intelligence. We've built powerful telescopes, developed sophisticated signal processing algorithms, listened to millions of star systems. The SETI program has been operating for over 60 years, and until now, we've heard nothing but cosmic silence. The Fermi paradox, the puzzling absence of evidence for other civilizations in a universe that should be teeming with life, has haunted us. But now, an interstellar object had entered our solar system, and it was broadcasting a signal that bore all the hallmarks of artificial origin, not from a distant star system light years away, but here, in our cosmic backyard, close enough to study in detail. 3I Atlas wasn't just a comet. It was a messenger, a probe, perhaps even an invitation to join a cosmic conversation that had been taking place long before humans emerged on Earth. It wouldn't be contained for long, despite our attempts to keep the discovery under wraps until we could be absolutely certain of our findings. Word leaked. Within a week, it was the biggest story on the planet. World leaders were calling for emergency sessions. Religious leaders were issuing statements. And the scientific community was mobilizing on a scale I'd never witnessed in my entire career. I was asked to brief the President and the National Security Council. I flew to Washington and found myself in the Situation Room, surrounded by generals, intelligence officials, and policymakers, all wanting to know what this meant for national security, for global stability, for the future of humanity. I told them what I knew, what we'd discovered, but I was careful to emphasize the uncertainty. We had detected a signal. We had evidence of structure and apparent intentionality. But we hadn't yet decoded the full message, if indeed there was a complete message to be decoded. The international response was swift and, I'm proud to say, remarkably cooperative. The United Nations established a special committee, the Committee on Interstellar Contact, chaired by the Secretary General, and including representatives from every nation with significant space capabilities. For perhaps the first time in modern history, humanity was confronting a challenge that transcended national boundaries, political ideologies, and cultural differences. We were all, suddenly and profoundly aware of our shared identity as one species, one civilization, facing the unknown together. Back at Harvard, the team had expanded dramatically. Cryptographers from the NSA, linguists studying the structure of language, mathematicians, physicists, even philosophers and anthropologists joined the effort to understand the 3-eye atlas signal. We set up a secure facility, brought in the world's most powerful computers, and began the painstaking work of deep analysis. The mathematical sequences embedded in the signal continued beyond the simple prime numbers we'd initially detected. As we analyzed more cycles, we now had months of continuous data. We found increasingly complex mathematical structures. There were references to pi, to e, to the golden ratio. There were geometric constructions, the Platonic solids, tessellations, fractals. It was as if someone was demonstrating, we know mathematics. We understand the fundamental patterns that govern the universe. We are like you. Dr. Elena Vasquez, a cognitive scientist from Stanford who had joined our team, made a fascinating observation. The progression of mathematical concepts in the signal appeared to follow a pedagogical structure. It started with the simplest concepts, counting, basic arithmetic, and built systematically to more advanced ideas. It's teaching us, she said. Or more accurately, it's establishing a common language. Mathematics is the only truly universal language. Any technological civilization would have discovered the same mathematical truths. This signal is creating a foundation for communication. Then we discovered the three-dimensional patterns. By mapping the amplitude and frequency variations across the 88-minute cycle, Rebecca found that the data could be interpreted as coordinates in three-dimensional space. When we plotted these coordinates, they formed geometric shapes. First simple ones like cubes and spheres, then more complex structures that looked almost biological, like spiral patterns similar to DNA helices or the logarithmic spirals we see in galaxies and nautilus shells. But the most shocking discovery came on day 63 of our analysis. Dr. James Wong, a specialist in information theory from MIT, noticed something in the timing structure of the signal pulses. The intervals between individual pulses within each 88-minute cycle weren't random. They encoded information using a binary system. Longer intervals represented ones, shorter intervals represented zeros. It was a straightforward encoding scheme, almost deliberately simple, as if designed to be easily recognized. When we decoded this binary data, we found images. Actual images. The first one was simple. A circle. Then a circle with a dot in the center, perhaps a representation of an atom, or a star with a planet. Then more complex images. What looked like a stellar system with multiple planets. Diagrams that might represent spacecraft or probes, and finally, an image that made everyone in the room fall silent. It was a map, a three-dimensional star map showing the positions of nearby stars, with one star clearly marked and a trajectory line extending from that star toward another star, our sun. This wasn't just a message, it was an explanation, a navigation chart, a declaration of origin. 3-Eye Atlas was telling us where it came from. The star system was approximately 87 light-years away, in the direction of the constellation Lyra. We immediately focused every available telescope on that region of space. The star was a G-type main sequence star, remarkably similar to our own sun. Early spectroscopic analysis suggested it had planets, though we'd need more detailed observations to confirm. But the implications were staggering. 87 light-years. If this probe had been traveling at a significant fraction of light speed, say 10%, it would have taken nearly 1,000 years to reach us. This was a mission planned and executed by a civilization with patience beyond our comprehension. With technology far beyond our own, I began working with a team of linguists and cognitive scientists to understand what else the signal might be telling us. Dr. Noam Finkelstein from Berkeley pointed out that the number 88 itself might be significant. In Chinese culture, he explained, 88 represents fortune, prosperity, and infinity. the double infinity symbol. In Western music, it's the number of keys on a standard piano. Could this be a hint about the importance of harmony, of mathematics expressed through sound? Or could it simply be a number that they knew would catch our attention because of its prevalence in our own culture? We also discovered temporal markers in the signal. Embedded within the mathematical sequences were what appeared to be references to astronomical events: the period of pulsars, the frequency of the cosmic microwave background, the rate of galactic rotation. These are cosmic constants, unchanging over timescales of millions of years. By including them, the designers of this signal were creating a kind of universal timestamp, a way for any civilization that detected the signal to understand not just where it came from, but when it was created. As the weeks passed, we extracted more and more information from the signal. There were hints of chemistry, sequences that might represent the structure of complex molecules, perhaps even the building blocks of life. There were physical diagrams that could represent propulsion systems or energy generation methods. And there were patterns we simply couldn't interpret, structures so complex and abstract that they might represent concepts or knowledge completely outside our current understanding. The philosophical implications kept me awake at night. Here was proof that we are not alone, that intelligence has arisen elsewhere in the universe, that someone out there had mastered interstellar travel and had deliberately sent a probe to our solar system. But why? Why now? Why us? The probe must have been launched centuries ago, long before we had radio telescopes, long before we could detect such a signal. Did they somehow know we would be here? Did they have the patience to send probes to countless star systems, hoping that intelligent life would eventually evolve to the point where it could receive the message? Or was this probe part of a vast network, a galactic internet of sorts, with thousands or millions of similar probes scattered throughout the galaxy, waiting for civilizations to reach the technological threshold necessary to detect them? Perhaps becoming aware of this network, receiving this invitation, was a rite of passage for emerging technological civilizations, a cosmic welcome to the neighborhood. 3 months after the initial detection, we held a press conference. Standing before cameras broadcasting to billions of people around the world, I presented our findings. I showed the mathematical sequences, the star map, the encoded images. I explained what we knew and, just as importantly, what we didn't know. I emphasized that this was just the beginning, that 3i Atlas was still transmitting, still in our solar system, and that we had an unprecedented opportunity to learn, to grow, to understand our place in a universe that was suddenly much less empty than we had believed. The signal continues. Every 88 minutes, like a cosmic clock, 3i Atlas sends its message into the void. We're still analyzing it, still finding new layers of meaning, still being surprised by the depth and sophistication of the communication. We've proposed a mission to intercept the object, to study it up close, perhaps even to send a signal of our own in response. Whatever 3i Atlas is, probe, messenger, artifact of a civilization we can barely imagine, it has given us the greatest gift: knowledge that we are not alone. In the vast darkness of space, across 87 light-years and nearly 1,000 years of travel, someone reached out. They said, in the universal language of mathematics and physics, we exist, we are here, and now, so are you. For a physicist who has spent his life studying the fundamental nature of reality, I can tell you this: the universe has just become infinitely more interesting, and the adventure of discovery has only begun.